Welcome to this tutorial. Kindly subscribe. Today we are looking at integrating factors for exactness of differential equations. Remember from our previous tutorial we have looked at exact differential equations and how we solve them. We have also looked at how to test whether a differential equation is exact. So today we want to look at something interesting called IF for integrating factors. Integrating factors basically convert a differential equation to become exact. So maybe a differential equation is not exact. So if you want to transform it to exact, then we use integrating factors. Use integrating factors. So if this is the integrating factor, is an integrating factor for exactness of this particular differential equation. So we say it's a integrating factor for that particular differential equations if you multiply every part of m and n with it, you don't change the solution, so the solution is still 0. So for this case you have changed it to become exact dE, to change to exact. So that particular dE, if you multiply by integration factors, you find that it's becoming exact dE, becoming exact differential equation. So the solution of differential equation, this one, is same as the exact dE transformed to that one. So if you solve that differential equation, you'll find that the solution is similar. Is same. So now let's look at how we do this from an example. Show that this particular fraction is an integrating factor for this equation, this differential equation, y dx plus x dy equal to 0. So for any value of n, then solve the dE by using n equal to 0 and n equal to 3. And then the question that we need to investigate is the solution same? Is the solution same for n when n is equal to 0 and n equal to 3? You have to investigate that. So what you need to do, we will multiply every part by integrating factor of the equation, of the differential equation, and hence we will come up with this. That's what we are getting, which is still equal to 0. So that from here we can get m, which is that. We can also get n, which is this. Now you want to test first whether we have converted the differential equation to exact. And how do we test that? From our previous tutorial we saw that the partial derivative of m in respect to y, if it's equal to the partial derivative of n in respect to x, then we say that particular dE is exact. So let's look at this. So you can see that is same as this. So this is true, and therefore the IF given is for sure the integrating factor for that dE, and therefore we are saying that because they have transformed the differential equation into exact differential equation. So that means this fraction is surely integrating factor for the equation given. Next part of the question is, suppose n is equal to 0. So if you say n is equal to 0 and substitute in here, yes, we substitute in here, you'll find that in here you'll find that the equation goes to this, and this new dE is a separable dE. How to solve separable dE? We have a tutorial up there, so you can check it up there, the tutorial on how solutions for separable differential equations. I have it there, so you can check it and how we solve this. It's very easy to solve. So in case you have question again on this, kindly leave a comment, and I'll be able to guide you on how we solve separable differential equations. So for n equal to 3, you'll find that after substituting the value of n, we are going to get this equation here. And this equation here is exact dE. Is exact dE. Is exact dE. It is an exact dE. So how to solve exact dE? We know how to solve exact dE from the previous tutorial, how to solve exact dE's differential equations. If you have a question again on that, you can leave a comment there, and I'll be able to guide on how we solve exact differential equations. So solving both the separable and exact dE, you'll find that the solutions are basically same. Xy equal to a constant. So either way, you arrive to the same solution, because they are all solutions for differential equations, or solution for differential equations. So if you have any question on this, kindly leave a comment, and I'll be able to come back to you. So kindly subscribe in this tutorial if you have not subscribed, and share also to your friends. Bye, until next time.